Hello, Mohammed. Good morning. Hello, developers from all over the world. Welcome to this workshop. This is 9 p.m. for me. I hope that the morning for you. Yeah, good morning. Good morning. We will wait about 7 minutes for more people to come. I have a question. Is there any API that provides me the access to create automation in Chainlink? Uh, I actually I think you cannot use an API to just create a subscription or do something like that. You can just create a automation in advance and use an API to do something with automation. Good afternoon, Akin Fanwa. And if you want to learn more about Chainlink, there is a new service called Chainlink Functions. We just released in last month, and you can use the Chainlink Functions to just make an API call to the outside world and move the unnormalized data to the smart contract. It will like the new version of an API. Hi everyone. Yeah, too early for Saturday. Let me check the time. So 4 more minutes for more people to come. Well, you have questions before I even start, and you learn a lot about the Chainlinks. So how many link tokens would I need once beta is over and the devs can start building? If you want to start building on the testnet like Sapolio or Mumbai, you can just get some test tokens from the faucet. I think about 15 or 20 links is enough for you. What packages needed to be installed for this workshop? You actually don't need to install any package because for this workshop, I just introduced the auto service provided by Chainlink, and I'm going to use a remix to do the demo. So if you can open the remix and input the Solidity code in the remix. The IDE will help you to install all the packages. And of course, we have some other workshops in following this workshop. It's gonna happen in April and May. If you want to learn more deep knowledge about Chainlink functions, about development tools, and about public chains, they may have some pull request. They need to install some packages in advance. Just keep an eye on that and comment and learn. Thank you for your questions. Hello. I'm new in the Web3 space. Do I stand a chance to partake this hackathon? Yeah, of course, of course. In Chainlink Hackathon, we encourage new developers to come and learn and to just watch what other people are doing and try your code and to implement what you want to do in the hackathon. And it's going to last for 1 month, and you can learn and build. It's a good opportunity to learn and also make some friends. If you want to find a team to just coding with some other developers as a team, you can go to the Discord, the Chainlink Discord. There is a channel called Teams or maybe members. You can post your requirement or just post your skills stack to see if you can find a team. Okay, cool. It's 9 p.m. for me, and the workshop is going to start. Thanks for all the developers coming here, and welcome to take part in the Chainlink Hackathon. And thank you, everyone, and good morning, good afternoon, and good evening. So let's start. Oh, before start, there are some other questions. How many Chainlink services are there in total? There are about 5 Chainlink services you are going to use in Hackathon. It's called Chainlink data feed, Chainlink functions, and Chainlink VRF, Chainlink automation, and Chainlink and API. I'm going to cover 4 of that in the workshop, and you can learn all the basic knowledge of this trust minimization service in this workshop and start building. And if you want to learn more about the details about different services, you can just go to the docs.chain.link. That is the documentation website of the Chainlink. You can learn the more details about every services. And I will show in the workshop. Don't worry. Okay, let's start. Let me just show my slides. Okay, hey everyone, good morning, good afternoon, and good evening. Hi to the developers from all over the world for this workshop, and welcome to take part in the Chainlink Hackathon. And my name is Frank. I am a developer advocate from the Chainlink Labs. I'm going to make a brief introduction about how the trust minimized services provided by Chainlink in this workshop. And if you want to learn more about the other services and get some deep understanding of the Chainlink about a public chain, or want to learn something about development tools, we also have other workshops in a series after this one. And just keep an eye on that and comment and learn. And welcome everyone. Okay, so in my presentation or in my workshop, there are going to be 3 parts. For the first one, I'm going to introduce what is an oracle and why we need that. And for the second part, I'm going to introduce the Chainlink trust minimized services, including the Chainlink data services and the Chainlink computing services. In the Chainlink data services, there are 2 services. The first one is a data feed. You can just get the price of a particular asset from the outside source. And the second one is called functions. You can use functions to get some unnormalized data or get some custom data. If you all the data you can get in the Web2 API, you can use functions to connect your smart contract to these APIs and build logic based on that. And after that, there are also the Chainlink computing service. The first one is VRF. You can rely on VRF to get a randomness on chain. and you can use automation to just automate functions in your smart contract. And all of these services can open up a huge number of the use cases. And I'm going to introduce all of them and do the demo for each service, so you can learn how to start and where you can find the documents. And at last, I will spend a little bit of time to share some useful information about the Chainlink community. As a developer or as a builder, when you have some problem, technical problem, you can find someone to help you. That is very important. Okay, so let's start. The first question we need to answer here is what is an oracle? Oracle is actually a new kind of the infrastructure that help developers to relay the data and computing services from the off-chain to on-chain smart contract. So maybe your next question is that why we typically need an infrastructure help us to relay the data and computing services. The short answer is that the smart contract on the blockchain just cannot actively get data from the outside world. So as we all know that the data saved on the blockchain, the biggest characteristics of the data saved on the blockchain is that every single piece saved on the blockchain has its own ownership, which means there is not a central authority that can remove or modify the data arbitrarily, because the data is actually saved across multiple nodes in the whole network. And in this scenario, in order to make sure that every different node keep the same data, there is a process called a consensus. The consensus is like just if there is a new update, if there is a data supposed to be updated or added to the blockchain, the state need to be updated. There must be a node under the whole network make a proposal to say like I want to execute this logic in the transaction, and I get this result. Can you guys just execute in the transaction I proposed, and to see if you can get the same result. If you get the same result, can you guys just update your own database correspondingly? So, and this node will just broadcast this news to the whole network. And every single node in this network will receive this proposal and execute what is told in the transaction to see if they can get the same result. If the same result is calculated, they will just update your databases, and the consensus is successful. And by after that, we can see that the transaction is written into the block, and the state is updated finally. So that is called the consensus. Everything sounds good, right? But think about this scenario. If I want to get a data from the outside API, maybe the temperature of the city where I'm living, maybe Hong Kong, maybe Beijing, or maybe New York City, there is a node make a proposal to say like I just get a temperature data from the outside API in Hong Kong, and that is 20 Celsius degree in Celsius. And can you guys just check the same API and get the result to see if you can have the same temperature data? If the result is the same, can you guys just like before to update your databases or just update this state? So what do you think? What do you think gonna happen next? Like before, after the node make the broadcast this news to the whole network, the different node in the network will just make an API call to the outside API. And let's first assume that every different node have the same access to the API. And do you think they will get the same answer? Maybe, but maybe not, because in the different time slot and the different people, even they call the same API, they may get the different answers. Because like in the 2 p.m., in the 2 p.m. 30, maybe the data provided by the API is different, or the API is down and the service is suspended, so the node cannot get a result from the API. So if the node cannot get the data, cannot get the same answers, the consensus cannot be passed. So the transaction cannot go through the consensus, and the data cannot be updated into the blockchain. And that is called an oracle problem. that is why the blockchain cannot get or fetch the data from the outside world by itself. And to summarize it, the blockchain is actually a deterministic system, and the blockchain can only handle the deterministic transaction. So what is an deterministic transaction? That is like no matter when, no matter who to execute this transaction, the same result will be calculated. For example, like 1 plus 1, and no matter who and no matter when to calculate 1 plus 1, the result will always be 2, and that is called a deterministic transaction. But if you want to make an API call to get data from the outside world, and if you want to get a random number, the different node will get different answers, and the different answers in the different node, so the transaction cannot go through the consensus. In this way, the blockchain cannot just handle the indeterminate transaction. And Oracle, by its name, is actually used to solve this problem. Oracle can help us to relay the services, relay the data, and relay anything we want from the off-chain to on-chain. Okay, so I will answer the questions after I go to the next section. Okay, so we've been talking about what is an oracle and what we needed. So let's go over some different types of the oracles. When the oracle, this concept is firstly introduced into the Web3 in the very early stage, there were a lot of the centralized oracles in the market. The process for the centralized oracle is pretty straightforward. Usually, the user will write a smart contract, and through this user smart contract, the developer can send a request and save that onto a event log. And the data on the event log can be caught by an off-chain centralized Oracle node. And this Oracle node with necessary data from the request will just use the predefined script in the server and get data from their data sources, and then get all the data and just write this data back to the smart contract. That is pretty straightforward, right? But actually, there is a problem called a single point failure. When you use a single node oracle, that you create a single point failure, because the data you rely on is actually fetched by a single node, and when there is something bad happens on this centralized node, the data will be controlled or exploited, and it will be harmful to your protocol. The users under your decentralized application may lose a lot of money on that. So think about this scenario, and the whole reason you want to build your applications on the decentralized network is because you want to rely on this decentralized network with hundreds of or even thousands of nodes to promise your application is very secure, very reliable, and very transparent. But if you are relying on a centralized node to feed the data to your smart contract, actually you create a single point failure. That was what we're saying, that you use a single node oracle, you create a single point failure. So the solution or the answer to this problem is that you can use a decentralized Oracle network instead of the single node Oracle node. For the decentralized Oracle network, you may have the 16 or you may have a 30 nodes under the network, and every different node will get the data or get calculated something by its own. And after all of this node get the result, they will talk to each other, just like a consensus algorithm, and then aggregate all the answers into a final report. And the DON, the decentralized Oracle network here, this guy, will send this aggregated result back to the decentralized Oracle network. And the decentralized Oracle network can verify if this result is valid and by checking the signatures or do some other necessary verifications. And if everything is fine, the decentralized Oracle network will save the aggregated result into its smart contracts that can be consumed by the other smart contract. So comparing to the single node Oracle, the decentralized Oracle network is actually kind of mimic the trust minimization that blockchain has. So they apply the trust minimized application, trust minimized service into the Oracle layer, or we can call it a data delivery layer, to make your Oracle is just a secure, just a reliable, and just a data tamper-proof like the blockchain. And for replicas being run by the independent and CPU-resistant node operators. That is the advantage of the decentralized Oracle network. We can also call it DON. So the Chainlink is kind of the decentralized Oracle network, and based on the DON, we also provide some services, including the data services and computing services. Under the data services, we have a Chainlink data feed and a Chainlink functions. With the Chainlink data feed, you can just get the price of the particular asset from the external source and use this asset in your smart contract. And if you want to use some custom data, like transportation data, like bank payment data, like temperature, you can use the Chainlink functions to get this kind of the unnormalized data and enable your smart contract to consume this data. And for the compute, you can use the Chainlink VRF to just get some randomness on chain, and you can also automate your automate your functions in your smart contract with the Chainlink automation. And all of these services are relying on the decentralized Oracle network. So decentralized Oracle network plus data and a computing service is Chainlink Web3 services. And the Chainlink Web3 services just connect the developer of the Web3 apps to the different blockchains, to the Web2 Lexis, to anything you want. And you can just combine your smart contract with a Chainlink Oracle network to just extend your smart contract to a hybrid smart contract, so, and build the logic based on the data from the mid world. Okay, so before I'm going to cover the knowledge of the data feed from the Chainlink, I'm going to see the questions. So if an Oracle node is centralized, what are security vulnerabilities? Yeah, if the Oracle node is centralized, it means that the centralized node could be attacked or exploited much easier than the decentralized network. And if the data provided by a centralized Oracle node is attacked or controlled, the decentralized application that relying on this centralized Oracle node will be influenced very easily, and the user of this decentralized application may lose a lot of money on that, or it is meaningless for us to build a decentralized application, because the reason we want to use the blockchain, we want to use the decentralized network is that we want to use the thousands of nodes in the network to promise our app is safe and transparent. But if the data feed part, the Oracle part is centralized, it is meaningless for us to build an application in the decentralized network. Very good question. Thank you. What happens to data quality nature when it is decentralized? Do they all provide the same different data? Yeah, for the decentralized Oracle network, every node will have a node operator, and every node operator is a different company or different organization, and they will operate a node to get data or calculate something by its own. So the answers may be different, and after they get the result, they will just use a aggregation algorithm. They do the aggregate. They just aggregate all the answers they get and to generate a final report. And maybe that is the median number from all the answers. Maybe that is the average number from all the answers. And then they can put this final result to the on-chain smart contract. Okay. And do you experience any hacker attacks on your oracles, and how do you prevent that? For Chainlink oracles, we have not experienced any attacks, and because we use the decentralized oracle network, so it is much harder for an attacker to just control the data. Does aggregation have time complexity? It will have some the different Oracle node will just we actually use the algorithm very similar to the consensus, but it's much easier than the algorithm consensus algorithm used by the Ethereum or other public chains. So it will cost less time, and that is efficient for the different node to just gather all the result, and then to calculate the median of this all the results and generate the final report. Okay, so let's continue. And so we first start with Chainlink data feed. For the Chainlink data feed, as I said before, if you are using if you are building something called DeFi, the decentralized finance, and there is a very decent chance for you to use the Chainlink data feed, because you need to know the value of the asset in your protocol. And in the data feed workflow, there is a part called Chainlink nodes. This is a decentralized Oracle node. We have like 16 or 32 nodes under a decentralized Oracle network, the DON. And every node under this network will get the data from the different providers. And providers will get the data from the other data sources. So after every node get the data and saved on the node, all the node in this decentralized Oracle network will talk to each other and aggregate the answers into a final report and send a report to a smart contract, the Chainlink data feed contract. And the Chainlink data feed contract is deployed by the Chainlink Labs. The smart contract will just verify the signatures and do some other necessary verifications to just certify the validity of the data. If the data is fine, the data of the price will be saved in this smart contract that can be consumed by the other consumer contract. So the data feed just enable you to consume the data of the price of the different assets and use this data into your consumer contract. So if you are building something related to the tokens, related to the price, you need to focus on the price of the tokens. You will need a data feed. And if you want to take a look at our data feed, you can directly go to the data.chain.link, and we have the different data node alive in the different networks. And this is an example. This is a data feed for the ETH. You can see the ETH/USD. And this oracles is a decentralized Oracle network. We have the 32 Oracle node under a network. And every node will get the data as I mentioned earlier. And after every node get the data, they will just generate a final answer. The final answer will show on the top left, which is $1,282.06 for the ETH. Of course, that is an older price. And and there are some other parameters I also want to mention. The first parameters is called deviation threshold, which is 0.5% in the ETH/USD. That means if the price of the Ethereum will automate more than 0.5%, there are going to be a new update for the ETH data feed. And the second parameter is called heartbeat. The heartbeat is usually a half hour or 1 hour. And if this period of time expires, there is a new update, no matter if the price of the asset is alternated more than 0.5% or not. If the time expires, there is a new update for the data feed. So from these two parameters, you can see the data feed does not constantly update the price data on the smart contract, because every time you want to write some data on the blockchain, you want to update some data, you need to spend some gas fees. That if we just constantly update the data on the smart contract, it will be very inefficient. And actually, we can just go to this website to take a look at date.chain.link. And in this website, you can see there are different networks, Ethereum mainnet, Polygon mainnet, and BNB chain, the Arbitrum. And in the different network, we have the different feeds like ETH/USD, the BTC/USD. And when you click that, you can see the exact same thing as I just showed in the slide. The different Oracle node under the decentralized Oracle network, and they will get a final report as this price and shown on the top left. And these are the two parameters I mentioned earlier. And that is a Chainlink data feed. And let's continue. So where you can use the data feed, as we talked earlier, the DeFi is the most obvious and widespread use cases of the data feed. So for example, you can use the data feed in the lending and borrowing protocol, because if you have a lending and borrowing protocol in the blockchain, the users or investors of your project will collateralize some asset on your protocol, on your smart contract, and get some USDT or USDC or some other stable coins back. So in this scenario, you need to care what is the value of the asset collateralized by the users. If the user collateralized $500, they can only just get back no more than $500. So if there is something wrong with the data of the price, with the price of the asset, the users will lose, the protocol will lose some money on that. So that is very important for the protocol like lending and borrowing to know the true value of the asset. The RV compound or Venus or using the Chainlink data feed. And except for that, we also can use the data feed on the mirror asset. The original idea for the mirror asset is that the protocol can allow the users to trade some asset not only from the blockchain native asset, but from the Web2 world, like the stock in the Web2 world. They can just mirror the asset in the Web2 world and to allow users to treat that. So that is also important for them to know the real value of the Web2 asset. And also for the stable coin, you can use the data feed to decide how many, what is the value of the asset collateralized on the protocol, and to decide how many stable coins can be issued based on this asset. So you also need a data feed to know the value of the collateralized asset. And also for the asset management and the options and the future, you can imagine how important the price of the data of the price of the asset is important for this kind of use case. Yeah, and next I will do a demo to show you how to use the data feed in the remix. And that is pretty simple. If you have the laptop with you, you can just try with me. Okay, before I do that, I can see if there is any questions I need to answer. So can we pull data points every minute? Do you mean that you want to just get the data in a very short time? Actually, from the smart contract, you just cannot get the data in a very high frequency, because the data can only be updated for one block generated. And for every block, there are going to be a time, maybe the 1 minute or maybe the 30 seconds for a new block generated. So it is very difficult for you to get a price every second. But for the every minute, it may be possible. What if the data source for all Chainlink nodes becomes same? We have someone to caring about that. I think it's quite expensive if Chainlink provides data on Ethereum mainnet. How Chainlink handles that? Yeah, as I said before, there are two parameters. We just don't constantly update the price. Only if the price is the price is alternate more than the threshold, and or the heartbeat the time of heartbeat expires, we just do the update. But for the other cases, we just don't constantly update the data. Okay. Yeah, there are a lot of questions. So I only have like a 1.5 hour today. So but for the slides, I only complete the data feed. We still have the Chainlink functions, Chainlink VRF, and the Chainlink automation. So I will first do the demo, and at the end, if we have more questions, we can stay here, and I will answer all the questions. So let me first do the data feed demo. And if you want to do the demo, you just try the Chainlink product. You can go to the docs.chain.link. That is the home of that is the Chainlink home for the developers. We provide the details of all the services here. You can see the first one is a data feed, and click that. You can see from the left panel there are content. Go to the using data feeds here, and we have a sample contract, and copy that sample contract and open the remix. For those who don't know about remix, the remix is an online IDE for Solidity code. And in the remix, just click the create. Oh, not this one. For this one, create a new file here, and we can call it data feed sample Solidity, and paste all the codes into the remix. And let me close that. Yeah, in this smart contract, there are something you need to care about. The first one is in the constructor. We need to give the smart contract the address of the price feed you want to get. For this one, that is a price feed for the BTC/USD, which will give you the price of the BTC. But if you want to use, you want to get the price of the other assets, you can find the different addresses in the documents in here, the price feed addresses. If you click this, you can see there are a lot of the public chains, the Ethereum, BNB chain, the Polygon, and all the other public chains. And under the different public chains, you have the different pairs and related address. And you can first decide which chain you want to use, and then to see which asset you want to, which price of the asset you want to get, and get the correct address. And then input this address in the constructor to create a new aggregator interface. And after you get this interface, you can use that in your functions. And maybe you are building a DeFi protocol. You have some other functions in your smart contract. You can still use the same thing to first instantiate a aggregator v3 interface and give it a correct address for the data feed, and then use this interface to get the latest data. The function is called latest round data because the price data is updated by round. So in the every round there are several data. First one is a round ID. You don't need to care about that. And the second one is a price. And the third one is started at, which means the timestamp for the round ID and all the other details. But in this example, we only care about the price, so we can only write the price here, and it will be fulfilled by the price feed we just created here. So we are using the Sepolia, which is a testnet of the Ethereum. So if you do not have the tokens, you can, if you do not have like the Ethereum or a link in the testnet, you can go to the faucet here. And in the faucet.chain.link to select the Ethereum Sepolia and write your wallet address to make this to check mark and log in by the Twitter. 1 second, and authorize the app. And then to check this I'm human to pass to the verify request. The computer keyboard. Not this one. Yep. Okay, and send a request. And after you send a request, your wallet will receive the 20 test link and 0.1 Sepolia Ethereum. Because I have already got enough tokens, so I will not wait this complete. And in the remix, let's switch back to the remix. And after the smart contract is complete, and you can go to here, compile the data feed sample, and everything is fine. There is a green check mark here. And after it's compiled, you can deploy this smart contract to the testnet. Before doing that, select inject provider. When you select this option, it means Remix will use your MetaMask rather than a local virtual machine. So click deploy, and your MetaMask gonna pop up. And click confirm. Yeah, I think we need to wait for about 30 seconds. The contract deployment is processing. Yep. After the smart contract deployed successfully, the price consumer v3, and we only have one functions here. It's called get latest price, which is this one. If I click this button, the functions will be called and the price will be returned. Let me collect that. See, this is a result. This let me just remove my face from the screen. Can you guys hear me now? How about now? Okay, thank you. Thank you very much. Yeah, I don't know how to just remove the image. Okay. So you need to see my face. I'm sorry about that. Okay, let's move to the second one, the Chainlink functions. The Chainlink functions is in beta, and the Chainlink functions are quite a new service. We just released this service in last month, right after the 8th Denver. And the Chainlink functions is a service to enable your smart contract to reach out and make an API call to the outside world. And for the Chainlink data feed, you can get a price of the particular asset. You can get a normalized data from the Chainlink data feed. But if you want to get some unnormalized data, if you want to get some custom data, maybe you want to get a weather and flight data to build a Web3 parametric insurance. For example, if the people just buy the insurance from your protocol, and if the flight is delayed, they can get some payout. They can be offered some payouts. And how do you do that? You need to get the data, get the flight data from the outside API, and then trigger the functions in your smart contract. But from the data feed, you cannot get this custom data. You cannot get the unnormalized data. This niche data cannot be fetched. But with the Chainlink functions, you can use the DON, the same DON, to fetch the data from the API in the Web2 world and to fulfill into your smart contract. This actually enables a huge number of the use cases. For example, for the weather and flight delay data, you can build insurance. And you can also get a greenhouse gas emission data to just generate some carbon asset for the market, because you want to most likely you need to use the IoT to track your what you do and your activity. And if this IoT device have an API, you can use the Chainlink functions to get data from the API to get a greenhouse gas emission. And you can also get election and sports data for the prediction markets and for the dynamic NFT. That is my favorite. And also for the asset and microeconomic data, you can just do some RWA, which is very popular today, the real world asset. You can get a RWA and increase the liquidity of the assets. So with the Chainlink functions, you can just extend the ability of your smart contract not only on blockchain, but also for all the data you can get from the Web2 world. And this is the Chainlink function workflow. The Chainlink function workflow in this graph you can see here. This one is a DON, the Decentralized Oracle Network. That is the same thing supporting the data feed. There are a lot of the Oracle node under this DON, and when you create a request from your smart contract, and you can write your request with some programming language like a JavaScript, right? You can use the JavaScript to write your request and use the smart contract to wrap your JavaScript code and any other necessary data into the request and send this request to the Chainlink function smart contract. The Chainlink function smart contract will check if you have enough balance and do some other check. And if everything is fine, the Chainlink function smart contract will save your send request into the event. And the data in the event can be caught by the DON. The DON will just make an API call using the data you wrapped in your request and to get the data from the API providers. And then after every node get a result, they will do a aggregation like before, like the data feed, and fulfill this result back to the smart contract using a fulfill request. And after that, you can get the data from the API providers. And the beauty of this is that as a developer or as a builder, you can only focus on this smart contract. You can only focus on your consumer smart contracts. You don't need to care about all of this, the server setup, the configurations, the Chainlink functions will take care of all of that. You just need to write your request in the JavaScript and send a request. And then wait a second, you can get a result back to your smart contract. And this will just help developers to have a higher efficiency and save a lot of time. And in order to show the how powerful the Chainlink functions and show some use cases in the Chainlink functions, we create a website called usechainlinkfunctions.com. If you want to, if you're interested in how to bridge the Web2 data and services into the Web3 smart contract, you can just go to this website and check the use cases on there. And you can see that we can use Chainlink functions to connect your smart contract to the AWS data exchange. The AWS data exchange is, as far as I can see, is the biggest API data market in the world. It includes some marketing data, includes transportation data, gaming data, and sales data. You can just connect your smart contract directly to this API with the Chainlink functions. And it's actually allows you to have the connectivity and the flexibility as any Web2 app has today. So just to check that. And you can also send the request to the Twilio to just use your API to send notifications, not only for the Web2 users, but also for Web3 users. And also for the Google Cloud BigQuery and the Meta NFT giveaway. And yeah, there is a lot of the use cases, and just go and check it. And we also, for the Chainlink functions, we also have a master class for the Chainlink functions. It's in the May 2nd. I think it should be, let me see, the 3 days later. And my colleague will give the master class on the Chainlink function. He will show how to use functions with the hard hat on how to use the Chainlink functions to send the notifications through Twilio to the artist, which is who is on the Spotify. That is a very cool use case. Just register now and to see the masterclass of the Chainlink functions. And for now, I just want to do a very simple Chainlink function demo and to show how everything works. But for more complex use case and for more use cases, use a website and learn the masterclass. So in order to use the Chainlink functions, first you need to go to the GitHub smart contract kit. And this is the official repo of the Chainlink Labs. And in the repositories, you just search functions. And there is a repo called Functions Hard Hat Starter Kit. The reason we want to use a function, we want to use a starter kit is because the Chainlink function is relatively new, so we do not have an UI for the Chainlink functions on the website. So we have to use JavaScript code, the hard hat, to send a request, send transactions on our behalf, and to try the Chainlink functions. And I click that in the code here, just a copy this link, the HTTPS link, and I go to the terminal. Let's zoom in the terminal. Okay, use a deep clone this link to just clone all the codes into your local, and you will have a new folder called Chainlink Hard Hat Starter Kit. And go to this folder, use npm install to first install all the dependencies defined in the package.json. Let me see the question. We cannot follow this demo unless our wallet address has been whitelisted. Correct. You have to be in the whitelist. And if your address is not in the whitelist, there will be your notification when you try to use that on the testnet. But it is very easy for you to get you in the whitelist. You just send a request and you will be in the whitelist maybe after 1 business day. Please answer my question. So what is your question? Oh, sorry. If I call the API, there is the full actual transaction on chain. So if every transaction costs more than $4, there is $16 for an API response. If that was on the Ethereum mainnet, it is financially feasible. For this question, if you want to, let me understand your question. Actually, you will not have 4 transactions on chain because you send a request to the smart contract of the Chainlink function, and this function will be get or be fetched by the DON, and there are a lot of the node under the DON, and every node will make a request to the API and get a result back, and all of this is off chain, and there is no transaction for this process. And only after the node aggregate the result and write it back, there will be a transaction. And you need to just fund your subscription, and the balance can be consumed by the DON. That is not expensive. I don't know if I answer your questions. And if you mean that the gas fee is expensive on the Ethereum mainnet, that is a problem. But we cannot solve that because in the Ethereum there are a lot of the nodes, thousands of nodes. So every computation or the transaction on the Ethereum is very expensive. And maybe the new technology in the future will solve this problem, but that cannot be solved by Chainlink. And of course, the reason we use the Ethereum is because we want our protocol or we want our app to be safe and reliable. And the safety and the reliability is depends on the cost. If the transaction costs more, the reliability and the safety is kind of relatively more safer and more reliable. And what kind of aggregation happens when a GET request simply return a JSON? You need to just get what you need in the JSON. There are going to be a path because in the JSON there are a bunch of the information. You need to know exactly which piece of data you are needing for your smart contract and exactly get that piece of the data. Okay, first let me just complete this demo and then I will answer the question. In NPM version 7, the NPM, let me see my NPM version. Yeah, it should be more than 7. Okay, so for now you get everything you need and go to this the repo. You can see there is there are instructions how you can use this repo, and you can also go to the documents here. Remember that if you need any information, if you need any details of the different services provided by Chainlink, just go to the document website. It will solve to most of your problem. And the second one you see here is the Chainlink functions. And go to the Chainlink functions here, the getting started. Yeah, the node version should be the 18, and git clone and change directory to the folder you just git clone, and use npm install to install the audit dependencies. And next is it's help you to just set the credentials in the hard hat, because the hard hat will send transactions on your behalf. So it has to know your secret key, and it has to have a RPC to the node. Maybe the Polygon Mumbai, maybe the Sepolia, maybe other the testnet. You need to get these 2 things: the RPC URL and the private key. And I have already prepared these 2 credentials and will input into the through the command line. So first, I'm going to input this command, the npx env enc, and set a password. I will give it 1, 2, 3, but don't use this password in the production. And then next, I need to set these 2 variables. The first one is is a private key. And if you don't know the private key, go to the MetaMask here and go to this one and account details. There is a button called export private key. Input your password here and the MetaMask will show the private key to you. For the use case, for the test or for something you want to try, just use a new wallet and do not use any do not save any real asset into your test wallet. And a private key, I've already got that, and I will put it here. This is my private key. And the second one, because we are using the Sepolia, we need to set this environment variable called Sepolia RPC URL. And also, I have already got my Sepolia URL in advance. And everything is fine. And if you don't know how to get the RPC, you can go to a website called alchemy.com and sign in. It will give you the different options to get the RPC URL into the different testnet, just like this. Okay, let me switch back to my terminal. So everything is fine. Let's go to the documents here. So we have already set our environment variables, and the next is to compile all the smart contracts. npx hard hat compile. There are a bunch of information, but don't worry. They are just the libraries and the dependencies, and the files is compiled or compiled successfully. And let's see the tutorials. You can see under the tutorials, there are a lot of things. The first is the request computation. In this first one, we will just request the DON, the Decentralized Oracle Network, to just execute our job, because we write our job in the JavaScript and we send our request to the Chainlink functions, and the Chainlink functions just put it in the event log, which can be calculated by the DON, and then the DON write back to the result to the smart contract. And the second one is call an API. Just the way we talked earlier, we can use the Chainlink functions to call the outside API. And the third one is telling you how to just encode the different types of the data. And there are a lot of things here. If you are interested in that, you can just read these tutorials when you have the problem. And I will just demo the first one because I want to save some time. It's already nearly 1 hour. So in this hard hat repo, we have the different branch. For the different tutorials, we use a different branch. So we need to first check to the tutorial one. And let me open that code to, sorry. Use the VS Code to see the see this architecture. And this one is environment variables. We saved just by using the env-enc command. And there are two things you need to care about. The first is under the folder contract. Here is a smart contract called function consumer. And you can see under this smart contract, there are two functions. The first one is called execute request. That is this thing. Here, the send request is the execute request. When you call this execute request and input the source, the secrets, the source is your JavaScript code, and the secrets is the credential information and other arguments, and the subscription ID and the gas limit, it will send a request to the Chainlink function smart contract. And after the smart contract, put this result, put this request into the event log and calculated by the DON will fulfill the result back to the fulfill request, this function. And if you have some custom logic, you can just write your custom logic under this function. And after the function consumer smart contract get the result, the result can directly be consumed by your logic. And the other thing you want to see is that in the function request source, this is the job you want DUN to execute. It's called a function dash request dash source. And actually, for this one, it's actually calculate the geometric mean of the arguments. And the arguments is let me check. Switch back to the document. The argument is 1, 2, 3, 4, 5, 6 to 10, and the job is to calculate the geometric mean of these numbers. And everything is good. Let me just simulate that. Sorry, in this one, the simulation. And without send this request to the blockchain, you can simulate on the local, and you use this command, the npx hard hat function simulate, and put it here to just run that. You can see the hard hat just simulate the everything will be happen on chain and write the result back. The result is 453. And you can also use some other command to just create a request and just create a subscription and put some balance in the subscription, and then to send the request in the real testnet. But I will not do that today. It's time consuming. Let's move to the next one. And let me see that questions. Oh, there are quite a lot of questions. First, this one is, has Chainlink data feeds experienced any trouble while providing data feed to certain DeFis before? The answer is no. That you can search the news and search anything you want, and you will not find any attack on the Chainlink data feed. And I'm using the Polygon ZK EVM for a while now, seeing the first transaction sent by the Vitalik against the owner guest of the launch ceremony. Hope to see it into. Yeah, in the future, we will integrate all the service into the different public chains. And ZK EVM is a future. I know that. So let me first complete all the content here, and then I can answer the questions. So next is Chainlink computing service. So we've been talking about the Chainlink data service for the data feed and the Chainlink functions, but we also provide some computing service like a Chainlink VRF and a Chainlink automation. The Chainlink VRF, you can get a randomness on chain for your NFT or maybe your some other decentralized application. And for the automation, I'm sorry, you can use it with your smart contract to automate your functions in a smart contract. And I will cover what kind of the use case could this service could be integrated. Okay, the first one, the Chainlink VRF. VRF stands for the verifiable random function. In the VRF, the why we need VRF, because from very recently, getting the randomness on chain is still an issue. In the previously conventional way of getting a randomness on chain is rely on some on-chain thing like a block hash or some other informations on chain. So that is very expensive for the smart contract to get this random number. And actually, this on-chain stuff could possibly controlled by the miners. If the miner have more than the 51% of the computing resources and a mining resource, and if you don't want to use the on-chain thing, you can use a centralized application, centralized server to provide you a random number. But you know that this way is not that safe, not that decentralized, not that transparent. If you rely on the centralized server to give you a random number, if the random number is controlled, actually your smart contract is influenced easily. So for the Chainlink VRF, we just use combines the on-chain thing with the off-chain oracle. The off-chain oracle will get a seed from the on-chain and use a private key and a algorithm called VRF to generate a random number and a proof. So these two things will be sent to the to on-chain smart contract called the VRF smart contract. The VRF will then verify this randomness is a true randomness by the proof. So from this way, you can just get a randomness, the true randomness from the oracle, because in the VRF, there is one seed, one result, that is a 1-to-1 algorithm. So the oracle off-chain cannot generate as many of the random number as by its half. It can only generate one random number with one seed, but this seed is on-chain and is public. This VRF will help you to open up a huge number of use cases. As I said earlier, the Chainlink VRF is widely used in the NFT ecosystem. You can use the NFT to just mint an NFT with the random trees. For example, there is a project called the XA Infinity, and you need to first mint a XA and then use XA to play to earn. From the very early stage of the XA, it uses Chainlink VRF to generate some random trees for the NFTs. And also for the NFT, like a Bored Ape Yacht Club, and you can the project use randomness to just airdrop some NFT to the holders. And except for the NFT creation and distribution, the VRF can also be used in the raffling and the fair selecting. If you have a ideal platform, you want to assign the opportunities to the different people in a whitelist or something like that, you can use the VRF to generate a randomness to decide which user is lucky ones or which users are not that lucky. And we have a blog here to just introduce 32 use cases. If you are interested in the use cases of the Chainlink VRF, just go to the blog of the Chainlink to check more details. And then let me do a demo for the VRF services. So first, just as before, we go to the documents here. And the Chainlink VRF is, let me refresh the page. This is the Chainlink VRF v2. That means the Chainlink VRF is version 2. And in the Chainlink VRF, go to the get a random number. And you will have a contract here. Let me copy that contract and switch back to the remix. In the file, create a new one called VRF sample solidity and paste out the code here. And in this smart contract, just as we do in the Chainlink functions, there are two functions you need to take a look at. The first one is request random words. Remember how we interact with the DON before? We need to first send a request through the contract, and when the DON get the result, it will use fulfill random words, use fulfill functions to feed the result back to the consumer's smart contract. So in the VRF, you send a request by this function, and you will receive the result by this function. And if you have some custom logic, you can write your logic under this transaction. Maybe you can write the NFT minting process in these functions, and the users can mint NFT randomly and get some random trees. And and we also have some configurations, the key hash, which is a gas lane. If you this is a maximum gas fee you allow the Chainlink DON to use for your VRF. If you needed the VRF in the very short time, you can select the high gas fee, the high gas lane. And if you don't care about that, you can select a gas lane with a low gas fee. And what is that? Let me give you an example. The supported network. It's called gas. Okay. Sorry. Oh, it should be this one. Yeah, here. For example, in the Ethereum mainnet, there are three options: the 200 GUI, the 500 GUI, and the 1000 GUI. So if you select this key hash, the maximum gas fee you allow the DON to use is the 200 GUI. And if you set this one, that is 1000 GUI. And for different the testnet, we are using this one. So because that is only a testnet, so we only have one options here for the 30 GUI for the supported testnet. That is the first one you need to care about. And the second one is a callback gas limit. That is a maximum gas limit you allow the DON to use to fulfill the randomness into your smart contract. And this is the number of words, means how many random words you want in this request. And to input all the configurations in the constructor, and you can use that. And because we are using a supported testnet, so we can use the same configuration. And then let me compile that. In the deployment tab, you can see that we need to have a parameter for the constructor, which is called a subscription ID. What is that? As I said before, every time you want DON to help you to get data or help you to calculate some result, you need to pay for the DON. The way you pay for that is you need to create a subscription and put some balance into your subscription, and then add the consumer, add this contract into the subscription. So I will show how to do that. So first, let me close that. First, go to the vrf.chain.link, and this is the UI for the Chainlink VRF randomness function. And go to the create a subscription, and this is your address. It will read the address from the MetaMask. And then create a subscription. The MetaMask gonna be gonna pop up and confirm. We need to wait for a little of time for the transactions done. It's done, and the UI need to detect that. Okay, after the subscription is created, and I need to add some funds. And I need to add 10 links into the subscription. Yeah. While I'm waiting, I will answer some questions. So if we choose 1000 GUI, we will have a priority to generate to get our VRF from the Chainlink oracles compared to others who picks the 500 GUI. Actually, for the DON for the VRF service, the DON will send the fulfill the result back to the smart contract when the average gas fee on the public chain is below the gas line you selected. If the if the average gas fee for the Ethereum mainnet is about 200 GUI, and no matter 1,000 or 500 GUI you choose, the Chainlink VRF will fulfill at the same time. So how fast you receive the fulfillment does not depending on the priority of the Chainlink VRF, but based on the gas fee of that public chain you are using. Okay, add a comment, consumers. Because we have not deployed our smart contract yet, so we do not have the consumer address yet, but we have a ID for our subscription. That is 1598. That is our subscription ID, and we just need this ID to deploy our VRF smart contract. To paste the ID here and click the deploy. And then just click confirm. Yes. I made a pull request for use Chainlink functions. Can you provide a review of that? Yeah, I can do that. Just send me your PR, and I will ask the owner of the repo to review that and just complete that PR. Okay, you can find me in the Discord, and you join the Chainlink Discord, and you can just put the information there, and I will see that. Okay, so our VRF consumer is deployed successfully, and we can see there is a bunch of the functions, and also we have a address of this contract, and copy this address and input this address in our VRF subscription. And here to copy that, add consumer, and confirm. And we need to wait about 30 seconds. And in the future, you can use the Chainlink functions in this way. You can just have a UI to create a subscription and fund this subscription and add consumers. But for now, the UI is not completed. So the better way to use the Chainlink functions is to use that hard hat starter kit. Okay, the consumer is added successfully. So you can see that we have a consumer here, which is a smart contract we just deployed. And this is a history that we create our subscription and fund it and add consumer. And then we can just request a random number here. So the function is this one. Remember what we see? Request the random words. When we call these functions, the smart contract will send a VRF request. Just click that. And confirm. And after this request is made, so there should be the request should be saved on the event log, and the event log can be called by the DON here, and we should see the request here. Let me refresh the page, and see we have a pending request. This is a VRF request we received, and the DON will just calculate the random number and write it back to the smart contract. But it is pending for the 22 seconds because the VRF need to wait for a new block and find a time slot to send this result back to the smart contract. And in the how we see this random number, we will have a request ID here. See this one. Every time when you make a request in the VRF will give you a request ID, and copy this request ID into this one. This one is a get request status. And actually this request is fulfilled. and the fulfilled is true, and this one is a random number returned by the Chainlink VRF. It is an array of the uint 256, so there are two elements in the array. The first one is this number, see, and here is a camel, and the second one is this one. So by this we get a two random number from the VRF. And if you want to have some custom logic, you can directly write the logic under this function. So cool. And let's move on to the last one I'm going to cover today, the Chainlink automation. The Chainlink automation is another Web3 service provided by Chainlink to just allow the users to automate the functions for your smart contract. And the Chainlink automation also relying on the DON, the decentralized Oracle network, the same mechanism from the as before. The DON will just check the conditions defined in the smart contract. You need to write some predefined conditions in the smart contract. If the conditions is met, and the smart contract will check it and find that is met, and to use a upkeep registry to send a transaction to the upkeep smart contract, that is the user's smart contract, to trigger this function. So the thing is like that. You first will just write some conditions in your smart contract. And when these conditions are met, maybe that is a time, maybe that is based on some outside data, and the smart contract, the DON will get this conditions status. If that is yes, it will trigger the functions you define in your smart contract. But if the conditions is not met yet, it will change to a new node in the DON and check the conditions in the next block. So that is how the Chainlink automation works. So you can rely on the off-chain smart contract and to just automate the functions in your smart contract in a secure and a very reliable way. And where I can use the Chainlink automations in the use case, the first one is it actually there are a lot of the use cases, and it opens a lot of the use cases in the Web3. And the first one, maybe you can use the chain automations to do a yield harvesting and a compounding. Think about the scenario. You just stake some asset on the protocol, and you will get some yield. For every hour or every 2 hours, or maybe every 2 days, you need to claim your yield and reinvest in your staking. And you can, by this way, you can increase your money in a compounding interest. And if you use the Chainlink automation to just automate the functions, you can just do it periodically and with a full commitment. And also, you can use the Chainlink automation in the DEX limit orders. As we all know, in the DEX, there is not a trading engine to watch if your order should be taken or not. In the decentralized exchange, the automatic market maker is used, and AMM is actually a pool, contains two types of tokens, and the ratio of the tokens will decide the price of token. So if you want to say like buy a token when the price of it is dropped from $15 to $10, and you can write this logic in your smart contract and set it as a predefined condition. And when this condition is met, the Chainlink automation will just trigger the functions of the smart contract and to make your order be taken by someone else. And also for the liquidation, when the asset is collateralized on the protocol, the value of the asset is dropped greatly. The protocol needs someone else to just keep watching that and liquidate the asset when this happens. And also for the dynamic NFT, you can just bind some metadata of the NFT with some real world data. For example, the soccer player, when the player make a goal in the match, you can just update this data in your NFT to make your NFT a dynamic NFT. Okay, cool. So next, I'm going to show the demo of the Chainlink automation. As before, we go to the documents. And we can see the automate contracts here. Oh, this guy is make an introduction, and you can go to the custom logic automation. This document tells what I was telling before, and you can find a this one, the create a compatible contract. You can find a sample code here. We also just copy this smart contract, and in the remix, go to the file, create a new file called automation sample.solidity, and paste the code here. Let me close this and minimize this. And in this smart contract, there are two functions. The first one is a check upkeep. In the check upkeep, you need to write your predefined conditions. For this one, it will check the the timestamp of the current time to minus the last timestamp to see the current time is like 5 minutes or 10 minutes more than the last timestamp. And if the time is greater than the interval we set before, these conditions can be checked by the Chainlink automation and to return the true. And after this condition is true, the Chainlink automation will execute and call the perform upkeep, and you can write some logic under these functions. So for this use case, for this example, we will first set the interval as maybe the 5 seconds or 10 seconds, and then every 10 seconds or every 5 seconds passed, the DON will check every block. The DON will check our check upkeep and to find if the 5 seconds or 10 seconds are passed. If that is true, the DON will just call the perform upkeep to do the automate. So that is a very simple use case using the Chainlink automation. So let's do that. And we also need a subscription of our Chainlink automation. Let's go to just like the VRF. It should be automation.chain.link here. And for this one, we first compile and deploy. So compile, everything is good. And we need to choose maybe 10 seconds and deploy our smart contract. Okay, confirm. After the smart contract deployed, we will find the third one under this tag, the deployed contracts. When we copy the address in the automation, we register a new upkeep that is a custom logic, and we need to include our smart contract address. And then next name, we can give it a name like a Hackathon 2023 automation. And we give it 10 links as an initial balance. And all the other information is optional and register the upkeep. Confirm. Yeah, and I'll answer a question. Does the on-chain Chainlink contract emit an EVM event on publishing a random number? Yeah, it will emit an event if a random number is generated and put on the and fulfilled to the user's smart contract. And our upkeep is created successfully. And let's see our upkeep in UI. And you can see that the owner address is my wallet address, and the upkeep there is an ID. And in the history, there is two things. First is found upkeep. We found upkeep with 10 test link. And the second event is that a perform upkeep. So why there is a transaction to perform upkeep? Because when we deploy our automation smart contract, we actually deploy this contract before we create a subscription, because when we create our upkeep registration, there is already 10 or 20 seconds passed. So the Chainlink upkeep, the Chainlink automation will see that like 10 seconds passed, so it will just perform the upkeep because the return value of the check upkeep is true. And let's say there should be the second call from the Chainlink automation. Let's refresh the page. And actually, there are two more because 20 seconds passed, I guess. And how can we see the result change in the smart contract? Go to the deployed tab, go to this smart contract, and there is a variable called counter. In the counter, this one, the first is the initial value of the counter is 0. So if the Chainlink automation calls these functions, the counter will +1, and the value of the counter will increment. And we can see the value of the counter now, so we can know if this function is called by the Chainlink automation. So we can click the counter, and it is 4. That means this function is called by Chainlink automation 4 times. And let's check on the UI. Yeah, 1, 2, 3, 4, 5. So the fifth line is just called maybe two seconds before. There are multiple calls to the Chainlink to the functions in the smart contract. So this is how we use Chainlink automation to automate a function under a smart contract. So cool. So yeah, that is pretty much I want to share in this workshop about the technologies and the services provided by Chainlink Oracle. And then at last, I will just spend about 1 minute to share some very useful information about the developer community. The first one is the documentation. From this workshop, I think you can see that how important is documentation when we do the development. And if you have any question, have any thing you want to learn about the Chainlink services, just go to the docs.chain.link, and you can find the documentation for all the services provided by Chainlink. And if you have some specific question, like how we can get Chainlink conversion contract other than something blah, 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 and if this question is not answered in the documentation, just go to the Ethereum.stake exchange and to post this question and tag this question with the Chainlink. So we will keep an eye on that. If the question is tagged with Chainlink, we will get the question and answer that. And also, you can go to the Chainlink Discord and to find a teammate in the hackathon, or just post some questions when you are using some Chainlink services. Okay. Yeah, that is pretty much I want to share today. And thank you for your time, and thank you for your listening. If you have any questions, if you have any suggestions, just let us know. Okay, and I will find some questions here. How can we increase the heartbeat of the Chainlink data feed for our DeFi? Does this cost increase dramatically if it is possible? If you are a developer or user of Chainlink feed, you cannot increase the heartbeat. The heartbeat is set by the DON. So if you are not the operators of the DON, you cannot increase this number. And does this cost increase dramatically? Yeah, if the heartbeat is shorter than now, maybe the 5 seconds or 10 seconds, that means every 5 seconds or every 10 seconds, the new transaction need to be written into the blockchain, and it will cost a lot of the gas fee. Can you please describe shortly how Chainlink takes advantage of the zero-knowledge proof? There indeed a service called DECO in Chainlink to make advantage of the zero-knowledge proof, but I'm not cover this content in this workshop. It's another topic, and that is very complicated. I'm not the right person to answer this question. If two people are using a Chainlink automation to liquidate a vote and both have paid the same gas, how does Chainlink decide to get the first transaction? The Chainlink functions actually, yeah, that is a very good question. So Chainlink functions actually will send the trigger the function maybe at the same time, and if when the check update is true, and who is the first one, it depends on maybe the mempool when the miners will put the different transactions in the different order. So that is nothing with the Chainlink automation. Yeah, that is a very good question. Actually, I do not it may not the correct answer. I will check with someone else and answer this question. Yeah, okay. So thank you very much, and thank you for your time. And yeah, it's great to meet all of the developers from all over the world. And welcome to our hackathon, and welcome to this workshop. I will be in the Discord and in the Stack Overflow all the time with the hackathon, and I will see all the questions from you, and I will try my best to help you guys. And if you have any questions, just reach me. Thank you, Mert. Oh, here is a new one. I'm new to blockchain technologies, but I need to ask with these projects, is there a necessity for the database? And if not, because of the data that is used from the blockchain? Well, that is a very good question. For this question, actually, the blockchain is not very efficient to save data, because when you save data or do some computation, every node in the network will do the same thing. So that is very expensive. The best practice, in my opinion, is that you build some logic in the database and the backend, and when it related to the asset or it related to the very important logic, you use the smart contract to define these important things and asset. But for the normal logic, like the API core and something else, you can still use the Web2 backend and a database. So the Web3 and Web2 is not enemies. We need to combine them together to generate a new decentralized application. But that is only my opinion. You maybe find a better practice. Okay, thank you, everyone. Thank you very much. And today's workshop, I think I learned a lot and know a lot of the developers. I'm also happy about that. And thank you, everyone. And see you in the hackathon. Bye.